Hi, welcome to Section 8 of this course, Statistical Inference in R. We cover these topics in this section: confidence intervals, z-tests, students' t-tests, skewness identification, exact binomial tests, Kolmogorov-Smirnov tests, the Pearson's chi-square test, the Wilcoxon rank sum and signed rank test, one-way ANOVA, two-way ANOVA, and linear regression. This is the first video of the section, Getting Confidence Intervals. Using confidence intervals allows us to estimate the interval range of unknown parameters in the data. In this video, we'll teach you methods that can help obtain confidence intervals in R. Ensure that you installed R on your operating system. The most prominent feature of R is that it implements a wide variety of statistical packages. Using these packages, it's easy to obtain descriptive statistics about a dataset or infer the distribution of a population from sample data. Moreover, with R's plotting capabilities, we can easily display data in a variety of charts. To apply statistical methods in R, the user can categorize the method of implementation into descriptive statistics and inferential statistics. Descriptive statistics. These are used to summarize the characteristics of data. The user can use mean and standard deviation to describe numerical data, and they can use frequency and percentages to describe categorical data. Inferential statistics. This is when, based on patterns within sample data, the user can infer the characteristics of the population. Methods relating to inferential statistics include hypothesis testing, data estimation, data correlation, and relationship modeling. Inference can be further extended to forecasting and estimation of unobserved values, either in or associated with the population being studied. Now, what exactly is confidence interval? Confidence intervals are constructed by confidence level. A 95% confidence interval means that 95% of the interval will include the population mean. On the other hand, a 95% confidence interval can be stated as 1-alpha, where alpha is the significance level. You can formulate the confidence interval calculation in this equation. Here, x bar is the sample means, z 1 minus alpha 2 is the critical value of significance level alpha, sigma is the known standard deviation, and n is the number of population. In R, we can use the q-norm function to obtain the z 1 alpha 2 critical value with the alpha given significance level. Let's get started. First, we generate a normal distribution using the R-norm function. Using plot, you can see the graph over here. Next, we'll sample 100 samples out of the population using sample population. Here you can see the value. At this point, we can obtain the z-score at a confidence of 99%. It's 0.995. We can now compute the standard deviation error and estimate the upper and lower bounds of the population mean. First, we call the upper function. Here, this is the output for that. Now let's call lower. And here is the output value. Now we'll shade the area between the lower and upper bound of the density plot. The code for that is this. When we run this code, we see the area is shaded. Now we can find the number z that the area under the standard normal curve between negative z and z is 0.95. To do this, let's use q-norm function. Let's now check what happens if we compute the range of confidence at 95% level. For upper 2, here's the range, 10.94565, and lower, 9.703933. We can then color the 95% confidence interval in blue using the polygon function. Here we have colored it blue. Moving on, let's take a look at how to obtain the confidence intervals of a Poisson distribution. We use the rpois function here. Then we apply mean to it. Here's a histogram of the Poisson distribution. Then we sample 100 instances from the population. We continue to sample these samples 1,000 times to generate 1,000 sample means. Finally, we can obtain the 95% confidence interval using a 2.5% sample quantile as the lower bound and the 97.5% sample quantile as the upper bound. Here you can see 97.5% and 3.5%. Besides using the bootstrapping method, we can also use boot.ci function from the boot package to obtain the confidence intervals. This is how it works. First, we load the boot package. We can now resample the data repeatedly using the boot function. Finally, we can use boot.ci to obtain the bootstrap confidence interval. Hence, we have obtained the bootstrap interval. Great! We understood confidence intervals in this video. In the next video, we'll perform z-tests.